So let us here discuss on transportation problem. Okay. When you go for operations management side as operations OM operations management side, we are using you are using the mathematical concepts. So when we say about manufacturing, it is not stopping with manufacturing alone. You manufacture and you stock it is not enough. You manufacture and you have to send it to the customers because only the customers use it. We can make a business and we can see the profit. So in that sense, in that line, it's somewhat related to I can say supply chain and other things about. So from the manufacturer's place, after it has come as a finished good, it has to reach to the customers, right? So in that sense, definitely it's going to be a cost. When we say it's a cost, it might be the cost might be bearable by the manufacturer itself, or sometimes the cost has to be borne by the customer. So probably we know all these concepts you might have done in economics, right? And here we are going to link one more concept called as demand and supply concept. Probably here sometimes will be calling as demand and supply, and sometimes will be called as requirement and supply, whatever it is. Just imagine this is a manufacturing area. There is only one manufacturing area, just one, and every month it produces 10,000 units of car. Okay, from here it has to supply to three depots or three showrooms or whatever it is. So let me name it as depot 1, depot 2 and depot 3. Probably in the first depot there may be a need of only 2000 cars. In the second depot there may be a need of 7500 cars, and in the third depot there may be a need of 500 cars. So if I check over here, I'm just matching with 10,000, but it need not be always, okay. This demand 2000, 7500 and 500, which is totaling up to 10,000, need not be the same as the supply always, which means what? Need not be in equilibrium state always. Sometimes this may be 10,500, but the demand may be only 10,000, okay, which means I'm discussing like colloquially the concept in economics where we say supply is more than demand. Or sometimes this may be just 9,500, but the demand in the depots or the customers need may be 10,000, which means here demand is greater than the supply. Okay, it need not be always the same. Here, because we are using the mathematical concept, we are going to make some assumption, that is, it has to give balance to it, which means we are trying to assume that demand is equal to supply, which means the requirement is equal to supply or whatever it is, okay, which means if I go completely mathematical side, we say the row total, probably you might have heard this terms, right? Row total should be equal to the column total, okay. So if I completely go mathematical side, I may take row total is equal to column total. Uh, Probably we can say it should be a balanced drawing. Okay, first thing. Second thing, the heading itself is named as transportation problem, which means most of the time we might be talking about cost, but sometimes what happens is the problem may be given that the manufacturer sends 2000 units to depot 1 where he sees a profit of rupees 2 per unit. See, this 2 rupees is not the cost here, but it's given in terms of profit. But throughout OM, our intention is to minimize the cost. Obviously, there is another one objective where we have to maximize the cost also. But our focus here will be completely, first focus here will be completely to minimize the cost. So this is the what we do here. Probably whether we go for linear programming or whether we go for assignment problem, where whenever we talk about optimality, our first intention will be to lower the cost alone. So lower the cost. In case profit is given, which means maximization, cost is minimization of the problem, and profit is maximization of the problem. If maximization is given, you have to convert it to minimization problem. So probably this may be maximization convert to minimization problem. Probably when I come for the other case, in case not given as a minimization problem, how I am going to convert that to minimization problem? If it is not a balanced problem, how we are going to convert that as a balanced problem? That will do it in later case. But here, when we talk about transportation problem, it should be first of all, it should be a standard problem. So what do you mean by standard problem? Is first, it should be check whether it's balanced. If it is balanced, no issues. check whether minimization is the objective. If it is minimization is the objective, no issues, you can carry on. If not, then you have to make it balanced and minimized. Okay. Please remember here, usually I say this one. When you go for assignment problem and transportation problem, whatever it is, the technique is similar only. But in the case of transportation problem, you have to balance the problem first, then you have to minimize it. Okay, this is the order. See, let me highlight here. This is the sequence you have to follow to make a problem as in a standard form. In the case of transportation problem, we have to make it balanced, then you have to make it minimized. If it's not balanced, make it balanced. If it is not minimization problem, make it a minimization problem. In the case of assignment problem, it's just ulta. Make it minimization problem first, then make it as a balanced problem. Okay, in the assignment problem, one-to-one assignment, you remember? Okay, so first over there in assignment problem, we'll make it minimized, then balanced. So now we are dealing with transportation problem. So in the order you have to follow, first balance the problem, then you go for minimizing. If not, minimization is given. Okay, if the problem is self standard form means you need not convert it. If it is not in standard form means you have to convert it. So this is what we'll be doing in the very first step. So when you go for transportation problem, so first one is you check whether it's a standard problem. If it is a standard problem, then you go for finding the beauty in this transportation problem is directly we'll go and find the solution. Okay. And that solution should be a feasible one. Feasible means is not optimal. That we'll be using two terms. One is feasible. Okay. One is optimal. Okay. If many constraints are given, if all the constraints get satisfied, we call that as feasible. See, there may be two solutions where all the constraints may be satisfied, but one will be minimizing the cost more. Please try to understand. There may be solution one and solution two, which may be for satisfying all the constraints. But when it comes to optimality, okay, we'll check which solution is giving more profit or minimizing the cost. Okay, so in that sense, whether S1 is better or S2 is better. So in that sense, we have to discuss here. So here in second point, that is after checking whether standardized, we'll go for finding the initial basic feasible solution. Initial basic feasible solution. Which means in this step itself we are going to find the problem. That is we are going to solve the problem. But we need to know whether it's optimal or not. So that's going to be the check step, which means we are going to check for optimality. That's the third step. Check for optimality. Okay, check for optimality. There is many method probably when you go for assignment problem, we have something like Hungarian method. When you go for simulation problem, we have something called as Monte Carlo simulation method. So likewise, here transportation, we are going to use a method called as UV method. Okay, we are going to use a method called as UV method to check the optimality. Before that, we are going to find the feasible solution, right? There are three ways you can find the feasible solution. First way, using the northwest corner. Okay, northwest corner is nothing but the top left corner will start from there. When I'll go for a first problem, I'll discuss in detail. I'm just telling all the methods where we're going to use here. The second method will be using the least cost method. Which table or which cell in the table gives the least cost will start over there. And third method is found by Vogel. Okay, Vogel. Vogel. It's called as Vogel's method. And sometimes it's also called, not sometimes, most of the time it's called as Vogel's approximation method. Because when you go for all the three methods, so what are the three methods we have done here? Northwest corner method, least cost method. So in short, we'll call this as Northwest corner method, NWCM method, least cost method, LCM method, and Vogel's method called as VAMS method, Vogel's approximation method. If you check or if you find the solution in all the three methods, you will definitely find that Vogel's approximation method will give you the minimum value compared to the three. So obviously our intention is to minimize the cost. So when you find the feasible solution using the Vogel's method, definitely that's going to be a minimized value. So the check for optimality may be helpful in the very first step itself. You check for optimality, and after checking for optimality, you find that it's not optimal, then obviously you have to repeat the steps. Okay. It's not just repeating the steps from the beginning. We'll make some small rearrangements. Okay, small rearrangements will be done, and that rearrangements Using that rearrangements, we'll go for finding whether it's optimal or not. So probably up to this level, we'll be dealing in the inter level, and in the final level, we have to go for small rearrangements in case it's what you call as doing different iterations and fighting. Okay. So let me go for problem number one from single material. Let us check. Actually, this is going to be an easy topic only. Okay. Only thing you have to understand the UV method, and other things are it's going to be simple. Okay. So let me go for problem number one. Yes, please join with me. There is a small theory content which I'm not going to discuss immediately. Let me go for the problem directly so that it will be helpful for you in understanding. Then I'll go for content. Okay, that is the theory content. So here's a problem. Let me have it on the board. Problem number one. This is problem number one. Try to understand the problem. This is a basic problem where we are covering all the models in the IBFS, that is initial basic feasible solution. All the models will be covered, which means we are going to discuss northwest corner method, okay, least cost method, and also VAMS method. All the three models are covered. And also we are going to check the optimality under the VAMS method. See, I'll just give some hint. When you are asked to find the feasible solution, or IBFS in short, you can use any of the three methods. If nothing is asked in the question, okay, if no name is mentioned in the question, I seriously request you to follow VAMS method. Okay, I in the sense I'm not personally advising you. I'm seriously telling you that no heading or no name is mentioned which method to use in the exam. We seriously tell you to use VAMS method only. Okay, if any method is mentioned, use Northwest Corner Rule method or LCM method, then you can go for following that method which is dictated in the question. Okay, so please pay attention. After finding the initial basic feasible solution, we'll go for checking for optimality. Again, if your question is to check for optimality and no mention of the names are given, again, we seriously request you to follow only Ram's method only. Okay. So if any mention is there with respect to Northwest Corner Rule method or Ram or LCA method, use it, or else you go for Ram's method. Okay. So let us go line by line. Okay. First, let me go for Northwest Corner Rule method. So let me work it out here. North, west, corner, rule method. Before that, please try to understand the content here. All terms are given in 100. Here is a depot. Depot is named as A1, A2, and A3. And the units are mentioned as B1, B2, B3, and B4. See, these things need not be same. There are 3 depots and 4 units. This need not be same. We have to check the column total and row total and check whether that's being balanced, because we need to check whether it's a standard problem, right? So if we go for the stock and requirement, can I get this value? Okay, I can find it here as 8, 10, 20, which is 38. Yes, 6, 8, 9, and 15. I think it is, yes, amounting to 38. So the total row and total column is the same. So it's a balanced problem. So let me write it over here. It's a balanced problem. Okay. And nothing is mentioned. So we assume that is related to cost only. So it's a minimization problem. So it's a standard problem. So no issue. You can directly go for finding the initial basic feasible solution. Is it okay? So what is this northwest corner rule method is? When we talk about this northwest corner rule method, just imagine you're running your business. Okay, let me take the space here. You're running your business. Okay, and there are 3 depots: A1, A2, A3, and there are 4 units: B1, B2, B3, and B4. Just remember, if you are a businessman with no logic or no mathematical knowledge, okay, you are like a lazy businessman, and there is a order coming from depot 1, depot 2, depot 3, and depot 4. Okay, how many stocks, how many requirements are there? 6 units requirements are there from all the 4 depots. What type of a businessman you are? Lazy fellow. Okay, you don't want to think logically. தாத்தா பாட்ட வந்து வீட்டு சொத்து உட்கார்ந்து அழிக்கலாம்னு இருப்பாங்க பாருங்க, எந்த லாஜிக்கும் அந்த மாதிரி லாஜிக்கும் இல்லாம பண்ணீங்கன்னா என்ன பண்ணிருப்பீங்க? Just you might have sent from A1 to B1. Am I right? You will not think logically at all. Am I right? Please try to understand. Okay, I'm not teasing or criticizing it. I'm just telling the logic behind NC and NWCA method. which means if you receive any requirement, you will not check which will be feasible. What you do? A1 and B1 அனுப்புப்பா அவ்வளவுதான் over, which means you will take this corner. You need not go and find the northeast west of directions and all. The top left corner or else first depot to first unit is what you call as the northwest corner, and we start the problem from there. Is it okay? Hope you can understand the logic here. So actually there's no logic. That's the logic, okay? I don't want to confuse you. There's no logic behind this. That's the logic. So let me start the problem. Let me have the numbers written. Sorry. Let me have the numbers written. So this is A1, A2, A3, B1, B2, B3, and B4. So A1 to B1 is 2, A2 to A1 to B2 is 3. I'm not doing anything, I'm just writing the question, okay? Don't think where I got this number, I'm just writing the question. It's actually when I write 2, 3, 5, 1, here it is given in brackets, which means negative value. Cost means negative only, no? That's why they mean in negative value, it's understood as negative. Okay, so and here it's 7, 3, 4, 6, and for A3 it is 4, 1, 7, and 2. And so this is the table given with the values. Apart from this, we have the stock given, which is 8. What is 8? The total stock in depot A1, am I right? 10 and 20. Whereas if you go for units, B1 it is 6, 8, 9, and 15. And we already know it totals up to 38. So we are over here. I have done nothing. I have just copied the question. Now I have to lead the problem using the top left corner. So if I go for the top left corner, so for convenience sake, let me have all the lines drawn so that it will be easy for you to understand in a better way. Okay, you need not go for drawing lines because you're doing professional course. You need not go for drawing line by line. Okay, if you're okay with the speed and you can manage without drawing lines, you can do it. Yes, you should just try to understand. So this is the question given. Okay, so let me start over here. I'm going to allocate from here. Here, what is the requirement? Please join. What is the requirement? 6 units is the requirement in unit B1. How much is the stock? 8 units stock is there. So no issues. Just give all the 6 units to B1. Okay. Give all the 6 units to B1. And how much stock will be left out here? 2 units. Am I right? Which means hereafter it becomes 0 over here for B1. Hereafter there is no stock need to be provided to B1. I can strike it off with this line. Usually we can do the striking off in the exam question paper also, in the answer paper also. It's allowed, it's happily allowed because this one technique we are using. Okay, we are not going to focus B1 hereafter. So from A1 to B1, it is how much? 6 units. All right. Next, go for the top left corner. So this B1 is striked out. So top left corner seems to be this one. The number of units that can be supported from A1 is only 2 units, but what's the requirement here? 8 units. So, see, this lazy businessman, he's not following any logic. So, what he does, he gives this 2 units. முதல்ல depot 1 ல இருந்து காலி பண்ணுங்க. Okay, அந்த மாதிரி concept. So, he gives this 2 units over here. So, when this 2 units goes away, so there is no other stocks in A1, but he still, B2 still requires 6 units. Am I right? Am I right? Then let us go for striking out A1, which means hereafter you cannot do anything with A1. Now go for the next top left corner. So I'm drawing a box over here. This is my next top left corner. And totally 6 units required, but there are 10 units we have, so no issues. You can completely allocate this 6 units over here, and the remaining 4 units will be available in A2. Now let me strike off B2. Now let us go for the top left corner. This is the top left corner. See, I have striked out this one, I have striked out this one only. So this one is remaining, right? So this becomes my top left corner. So over here, it is only 4 units available, but he requires 9 units. So just allocate 4 units over here. So remaining 5 units is yet to be supplied. And nothing to do with A2. So strike off this line and only left out with A3, B3 and B4. So the top left corner is this one, and 5 units are in requirement, so 5 and remaining 15. So definitely this 15 and this 15 has to match. That's why we say it's a balance problem. So allocate 15 over here. So we have to check what is the total cost over here. So for A1 to B1 it is 6. A1 to B2 it is 2 units. Okay, not 2 units, sorry. 2 rupees cost. So instead of writing this one, what I can do is I can go directly with respect to cost. So A1 to B1 is 2 into 6. Am I right? 6 units and 2 rupees cost. A1 to B2 it is 2 units and 3 rupees cost. A1 to B2 is over there. Then A2 to B2 it is 6 units, 3 rupees each. Then A2 to B3 is 4 units and 4 rupees each. Then I go for A3. A3 to B3 it is 7 units, so 5 into 7. And A3 to B4 is 15 units, so 15 into 2. Yes, can I get the phone total value? I think it's 11,700. 117, but it's given in hundreds, so 11,500 rupees is the total cost. Is it okay? This is using NWCM method. Is it okay? Can you just go through the response of LCM method? LCM, it stands for least cost method. Okay, least cost method. In short, we can use it as LCM directly. Let me have the questions directly copied from the question, data directly copied from the question. Okay, it's 2, that is A1, A2, A3, okay, B1, B2, B3, and B4, the stock and the requirement. Okay, so the question is 2, 3, 5, 1, 7, 3, 4, 6, 4, 1, 7, 2. Is it okay? I have not nothing. I have just copied from the question. It's the data copied from the question alone. After this, I am going to start working out. So the let me have the stop also noted 8, 10, 20, and here it is 6, 8, 9, and 15. Okay. The only issue with this question is you have to copy the data correctly. If you copy the data correctly, there's nothing else to do. You can directly get the answer. Please try to understand the heading is least cost method, which means from the overall table, you'll find the least cost. Okay. You just check what is the least cost over here. You can find two ones. So from A1 to B4 is least, and from A3 to B2 is least. So anything you can use, but usually what we do is we'll go from A1 because we have to follow logic, but again, you should not get over confused. So when you go for A1 to B4, what is the stock required here? 8. What's the what's the stock required here? 8. What is the availability? 8. So it's same, no issue. So we can directly give it and we can strike it out. Okay. Oh, sorry. I got diverted. Sorry. We are talking about this one. So let me have posted over here. Stock in requirement is 15, but the stock available in A1 is 8. So what I can do is I can allocate this full 8 over here. So hereafter it will become 0. So I can strike off this area. But there is a still need of 7 units balance. Am I right? Then from the remaining A2 and A3 values, I'll go for the least one. So we have 1 over here. Let me allocate over here. So 8 is the requirement, 20 is available. So let me allocate all the 8 over here. So left out in go down A3 will be 12. So let me strike it off this one. Okay, let me strike it off this one. So let me strike off this one. Then from the left down, here it is 2 units. There is 2 rupees is the lowest cost, and 7 is over here, 12 is over here. So I can give all the 7 units from A3. So left out will be 5. So nothing to do with B4 hereafter. Now let me strike it off. And from the remaining, we have 2, 4. So let me have 2, 4 means what? Here is 1, 4 and here is 1, 4. So let me go for allocating this 4 over here. So here it is 9 and here it is 10. So I can allocate all the 9 from go down to that is A2. So 1 unit will be pending and there is nothing to do with B3. So Let me strike it off. Okay, so let me strike it off. Then from this 4 and 7, I can go directly for this 4 where 5 units is the pending from the godown. So 5 units is allocated. So let me strike off this and write this as 1 unit pending. Okay, so this is done. I can strike it out and the left out is this one. And definitely it will match. It is not matching because we have made it as a balanced one, right? So it has to match. So 1 unit is the available in the stock and 1 unit is the requirement. So it's one directly you can allocate it. Now let us find the cost. So from A1 to B4, it is 8 units and 1 rupee costage. A2 to B1, it is 1 unit required, 7 rupees cost. And A2 to B3, it is 9 units and 4 rupees each cost. Then A3 to how much? 15, 5, right? So this is A3 to B1, which is 5 units, 4 cost each. Then A3 to B2, which is 8 units, 1 cost each. And A3 to B4, which is 7 units and 2 cost each. So I think it sums up to 9,300 rupees, which is 93. It given in 100, so 9,300 rupees. See, when you go for when we were discussing with respect to Northwest Corner Rule method, it was 11,500. But whereas when we discuss with respect to least cost method, because least cost method, we are having some at least basic logic, right? So this is not a lazy fellow. Okay. So 9,300 seems to be better compared to NWCM. Next, we'll go for VAMS method. Already we have discussed that VAMS method, the name itself is having approximation method, which means this is going to be a answer solution closer to the feasible, closer to the optimality. So definitely you'll get a value lesser than least cost method. See, Northwest Corner Rule method is a lazy businessman. Least cost method is a businessman. Now we'll use VAMS method. He's a brilliant businessman. Okay. So I just request you to go for the LCA method. If any doubts, we'll discuss. And let us discuss the third method on VAMS method. VAMS method, as I was telling, he is a brilliant businessman. So he follows mathematics over here. So we have to go bit mathematically, but not too much of mathematics. He's completely using a logic. Already we have discussed this one in assignment problem, and in many cases, usually we'll go something called as penalty method. I might have discussed you when I'm discussing the other topics, penalty method. When we say penalty method, see, you score. For example, there is an exam conducted. Yourself X, you score 90 marks. Okay. There is another one person Y. Okay. He scores 50 marks. How you compare? You should not say I scored 90 marks. Okay. How you compare? You have to compare that you have scored 40 marks extra. Okay. You have to compare in this way. This is what you call as penalty method. Now, the same concept we are going to discuss here in depots and units. For example, let me go for depot A1 to B1. How much is cost? I think it's 2 rupees it cost. If from A1 you are sending it to B2, it costs 3 rupees from B2. Sorry, A2 to A1 to B2. It costs 3 rupees. Okay. Look, for probably for convenience sake, let me have the values written. So we have A1, A2, A3, A3, right? Up to A3 we have. And here B1, B2, B3, and B4. What's the value? I think it's 2, 3, 5, 1. Kindly check the value if I'm wrong. Please help me out. 7, 3, 4, 6, and here 4, 1, 7, and 2. Okay. And let me have the stock also written. So yeah, I'm not doing anything. I'm just carrying over the question. Okay. I'm just writing the questions only. I'm not doing anything. Please highlight. So this is the stock. What's the stock? 8, 10, and 20. What's the requirement? 6, 8, 9, and 50. Okay, so this is the question, right? Now come for this logic. The logic here behind is penalty. If A1 to 2, see 2, or A1 to B to 3. So if I am carrying over from A1 to B1, it is 2. A1 to B3 is 3. We will not say it's 3 rupees cost. We will say that the difference, it is 1 rupee extra cost. Okay. Which means instead of sending from A1 to B1, if you send to A1 to B2, it is costing heavier. Ultimately, your profit is going to reduce. Is it okay? Again, you can ask me, ma'am, if you apply this logic, then why not we consider A1 to B4, ma'am? Yes, super question. When we consider A1 to B4, how much it costs? 1 rupee. See here we have the table. So when we consider this A1 to B4, it costs only 1 rupee. Whereas if you go for any other units, either a B1 or B2 or B3, it's going to cost extra money. So only if you send from A1 to B4, it's going to be a minimized cost. Am I right? It's going to be a minimized cost. So if you understand in this way, then you can easily apply penalty method. And what is beauty in this penalty method is for each and every depot, he's going to compare two values. One is the very least value, okay, very least value, and the next least value, okay, the next least value. If I go for A1, the least value is to B4. Am I right? A1, if you're sending the units from A1 to B4 is 1 rupee, what is the next least value? Sending from A1 to B1 is 2 rupee. If you do this mathematically, find the lowest value, 1. Find the next least value, 2. Subtract another 1. So you will write it as 1 over here. Okay. Okay. You will write this as difference. This difference 1 over here. This you have to do for all the depots and all the units. This is the highlight of Ogle. Usually everywhere we use penalty method, but Ogle's approximation, Ogle used in such a way that he applied the penalty method with little more logic. Okay, with little more logic. So let me go over here, BAMS method. Let me start the working. So you know the logic, right? What you have to do, you have to find the least value and the next least value and subtract. In case, in one case you get 2 and 2, you write the 0. Okay, please try to understand. In case, for example, if you have 2, 3, 5, and 2, you should not write 2 and 3 and 1. So you have to write this as 0 because you have 2. The next value also is going to consider as 2 only. You have to write it as 0 because if there's a tie-up, you have to focus on this one, right? So let me continue. So here we'll go for, actually it's a repetition process. You have to repeat, you have to repeat, you have to repeat. So we'll go for first one, that is first iteration or whatever it is. It's 1 and 2. Okay, so you take as 1, 2 minus 1, 1. Okay, then you go for A2. It's, I have 3 and 4, which is 1. Am I right? Then you go for A3. I have 1 and 2, which is 1. Likewise, I repeat it for units also. So let me have this as column number 1 here. I have 2 and 4, so it's 2. I have 3 and 1, so it's 2. I have 4 and 5, so it's 1. And I have 1 and 2, it's 1. Okay. So you go for finding the highest penalty. Highest penalty, you find two values are here. Actually, to say so, you can take anything, but usually I use this logic because some international authors use this logic. Whenever there is a tie-up, what we do here is, if the tie-up is over here, this side, we'll go from top to bottom. If the tie-up is over here, we'll go from left to right. Okay. So here we have two twos. So I'll consider this two over here. Okay. So ரெண்டு two வந்துச்சுன்னா repetition இருக்குல்ல. So first two நம்ம consider பண்ணிப்போம். இதே top to bottom னா மேல இருக்க two consider பண்ணிப்போம். Is it okay? So if I consider this one, and which means what? We are focusing on B1. Okay. Please try to understand the logic. We are focusing on not the depot. We are focusing on unit. When you focus on the unit, from A1 to B1 is 2, from A2 to B1 is 7, from A3 to B1 is 4. So ultimately what the depot will do, sorry, what the unit will do, B1 வந்து buyer என்ன பண்ணுவாரு, A1 ல வந்து காஸ்ட் கம்மி, அப்ப A1 ல தான் வாங்குவாரு. So he is going to buy in A1. Okay, please try to understand, he is going to buy in A1. So let me write it over here. Okay, so how much he is going to get it from A1? How much is there? 6 units he required. How much is there? 8 units is there. So you can completely allocate the 6 units. So you can write 6 over here. Is it okay? So once you write it, please don't hesitate to strike it out. You can boldly strike it out. Okay. Then we'll go for second repetition. So the same thing has to be repeated. Okay. So when you talk about Vogel, he is using the penalty method with a small logic, and along with that, he is going to apply the least cost method in particular depot or unit. So okay. Now we'll go for second category part, that is second iteration. Now from the remaining rows and columns, you have to find the penalties. So over here is 2. Why it is 2? 1 and 3 is there. And over here is 1. Over here is also 1. Whereas if you go for this side, the units, here we have strike it out. So kindly have a dash. Here is 1 and 3. So 2. Here is 4 and 5. So 1. And here is 1 and 2. So 1. Okay. And if you find a tie-up like this, see here is 1, 2. Okay, here is also 1, 2. Okay, you can do anything, but usually mathematically what I do is I will go from row wise. Okay, because I have studied not this as an application paper in my school days, in my college days. I have done this as my major paper. So what we usually do is from where it goes. So from A1 to B4, or because B4 is going to be a smallest value, so we'll focus on that way. But economically side, what they see is we are talking about cost. So wherever you find the cost less, you can apply over there. So probably if you check over here and if you check over here, you find this one is least here, one is least here, and in both the sides is 8. So there is no confusion at this point, but sometimes we get some confusion. Okay. But usually I follow this. Definitely, if you follow differently, there may be a slight changes, but you need not worry. In exam, it is accepted. Okay, you might be getting a different answer when you compare with your friend's answer. So that's why we say usually when you return from your exam, after writing the exam, please don't compare your answers with your friends. Okay, there may be a slight change, but it's accepted. No worries. Okay. So here I'm going to follow this two. Okay. So this two. So let me have the writings. This two. So what is the least value here? 1 and 8 units. I think I did not strike out this value. It's only 2 remaining. So let me allocate 2 over here. Okay, then I can strike off this one, and remaining if it goes here will be 13 units. Am I right? Yes. Then let me go for third iteration. Here is dash, here is 2, here is 3, and here is 4. Whereas here, third iteration, your dash 1 and 1. So the highest penalty is over here for 4. So the least cost is 2 over here, and 30 units are the requirement. Please supply it, whereas 7 will be remaining. Okay. Now you can please strike for B4. Now let us go for fourth iteration, dash 2, 3, dash, and over here it's dash 1 and 5. 6, sorry, 1 and 7, so 6 here. Okay, so this is the highest penalty, and the lowest cost over here is this one here. And what is the requirement? 8 units, but only 7 are available in A3. So allocate all the 7 over here. So if you allocate, only 1 will be remaining, and strike it off A3. Okay. So you can go for fifth iteration, but you have directly only 3 and 4 here. So you can directly allocate over here. So 1 is the required, 3 is the lowest cost. So allocate 1 over here. So this will go off, and 9 will be remaining, and allocate the remaining 9 over here. Okay. So if you now check the values, A1 to A1 to B1, it is 6 units, 2 cost each. A1 to B4, it is 2 units and 1 rupees. Then A2 to B2, it is, I think, 1 into 3. Then A3 to B4, it is 4 into 9. Okay. Then A3 to B2, it is 7 into 1. And A3 to B4, it is 13 into 2. So you can please check the total cost is 8,600. See, can you find it? Northwest corner rule method, we got 11,700. Okay. In the case of LCM method, we got 9,300, and in the case of Ogle's method, we got now 8,600. See, that's why we named this as approximation method. See, among the three values, definitely not only for this problem, all the problems BAPS method because we are applying more of logic, right? So BAPS method will definitely give the minimum value. That's why we say this is closely related to optimality. Obviously, we cannot confirm the optimality unless you check it. So, cannot say it's an optimal solution. That's what we say is a feasible solution. But this gives you the close optimality. So, please I try to understand the question. If the question is to find the optimal solution, you have to go for the next step. If the question is to asking you to find the basic feasible solution, then till VAMS method. That is, you do only the VAMS method, that's enough. Okay. Yes, please. Second. So we go for VAMS method. Using the VAMS method, we have found a table, right? That is the allocation table. So let me have those columns written. So kindly join with me. It's quite important. You need to understand the logic behind here. So let me have all the column headings and no headings written. A1, A2, A3, B1, B2, B3, and B4. Where and all you had the allocation in VAMS method. Okay, please try to understand. Where and all you had the allocation in VAMS method. That one we are going to classify the heading as occupied cells. So allocation is there in VAMS method, right? We are going to name that as occupied cells. Okay. Actually, the logic behind here is we are going to check whether there is any negative cost anywhere. You may ask me, ma'am, how a cost can be negative, ma'am? Either it will be no cost, zero, or there will be some cost, positive value. Can be there a negative value? That's what I'm trying to say. There can be no negative value. So if in my table, in proceeding further, if I get a negative value, I'm going to say then it's not optimal, which means I should get only positive value. When I'm talking about this negative value, I'm going to define a new cost called as dummy cost. Okay, please try to understand. Okay, dummy cost. What is this dummy cost named as Dij is equal to Cij minus Ui plus Vj. Don't get confused. Don't see this as a formula and something and all. It's quite a very easy logic. What is this Ui and Vj? Probably, if we talk about the problem, please try to understand. It's quite important. From A1 to B1, how much is cost per? 2 rupees. Am I right? A1 to B1, it costs 2 rupees. Now tell me, who has to bear this cost? Please join. Who has to bear this cost? Or if I ask you, what are the different options that a person can bear a cost? You will say, ma'am, either A1, who's the supplier, ma'am? So A1 will completely bear 2 rupees. So directly A1 is going to bear the cost, ma'am. So B1 will not bear any cost, so 0 rupees, ma'am. Or you may say that A1, the supplier, ma'am, he is not directly going to bear the cost. So only B1 has to bear the full cost, ma'am. Okay, that also may be an option. Or there is one option where they can both share the cost. Okay. This value we are going to name as U and these. Okay, this value we are going to name as U and these. Actually, now these are the depots. Okay, and these are the units. U we will allocate for the term U. We will allocate for depots, and the term V we will allocate for units. But sometimes if you are getting a different problem where units and depots, that's rows and columns are interchanged, you should not get confused, right? So we have to go a bit mathematically. You allocate for rows and V you will allocate for columns. Please remember this thing. You can ask me, what is this U and V, man? Yes, that's a very beautiful question. You're going to find a dummy cost where you will use dVj is equal to Cij minus Ui plus Vj. Our question is, what is this Ui and Vj? We are going to find using the occupied cells. Okay, from where? Using VAMS method, right? We are going to find the UIs and VJs over there. And what is the CI and Cij? It is from directly taken from the question. Okay, the direct cost given in the question. So from occupied cells, we are going to find UI and VJ, and we are going to find this Dij for unoccupied cells. If you don't get yourself overloaded, I'll explain each and everything in detail again when I go for the problem. This is concept I'm explaining. So what we are going to do, we are going to find whether this Dij is negative. If it is negative, no optimality is reached. Okay. If it is negative, no optimality is reached. So we have to get either 0 or positive. So this Dij, okay, this Dij should be What? Greater than or equal to 0 means it's optimal. If it is less than 0 means no optimality. You have to proceed with small arrangements in the problem and check. What is this Dij? As I discussed now, Dij is nothing but Cij minus Ui plus Vj. How are you going to find this Ui and Vj? From the VAMS method using the occupied cells. What is the Cij? It's the data given in the question. And please make a note, you are going to find this Dij only for unoccupied cells. Okay, so let me proceed with this. So our first one is to have the notings with respect to, is there all available in the material bar. So you need not make a note of it. It's all there available in the material. So directly let me go for the allocations. You need not have the allocations fully written. You can directly have the values written. Okay, what values? The cost values written for occupied cells which you found it in VAMS method. Please highlight this one table. You'll actually have three tables over here. This one table is you're going to find the U and V values, okay, using the occupied cells in the VAMS method. So if you go for the VAMS method, we have found this cell is occupied. Is it okay? So let me write it 2 here. And this cell is occupied 1 here. Okay, this 2 and this 1 is the question value. The allocation is done over here and over here. That's why I'm writing 2 and 1 over here. Okay. Okay. Then for A2, here it was allocated, here it was allocated. For A3, here it was allocated, here it was allocated, and here it was allocated. Hope it is okay. Can you please give your concurrence? Whether shall I proceed? If this is okay till here, please confirm. Yes, please. Yes, please. Shall I continue? Yeah, thank you, Pam. So now let me proceed. Our intention is to find U and V over here. Where are U's to be placed? U is meant for row. So these are the rows, right? So I'm going to place U over here. So this is going to be U1, this is going to be U2, and this is going to be U3. Let us find the value. And V is to be placed over here. So this I'll name it as V1, V2, V3, and V4. You have to make an assumption. Okay, any one value you have to take it zero. Any one your wish, you can take anything zero. But usually we follow a logic. See, ultimately, what is your aim? You're going to find U's and V's. Okay, U values and V values. So check which which row, which because you're going to focus from U or V, which row or which column has more number of values. If you go and check over here, here are two values. Okay, here are only one value, so it's not going to be helpful for us. Here are two values. Okay, here are two values. Two value. Okay. Here is also two value. Here is three value. Okay. Anything you can use. Sorry, I did something wrong. Sorry, I wrote this one wrong. This is actually two over here. Am I right? There's actually one over here and two over here. Am I right? Please check. This is one and this is two over here. Okay. Please check. Yeah. Thank you, bro. So here is two value. So everywhere I have two, so I can take anything. So for my assumption, what I'm going to do here is I'm going to assume, please highlight, I'm going to assume this value to be zero. I'll place a star mark. You can assume anything. I'm assuming this value to be zero. And we have already discussed that A1 to B4, the cost is 1 rupee. U is the cost borne by A, which is 0 rupees means B4 has to bear the cost how much? 1 rupee, right? So B value is going to be 1. So this value I can write it as 1. Is it okay? So this value I can write it as 1. This is 1. That's why we say U plus V is equal to Cij. Okay, what is this U? 1. What is the Cij? Sorry, U is 0, right? U is 0. What is the Cij? 1. So what has to so for using U1 and find V commas is going to be 2. Okay. Using this 2, what I can do, I cannot do anything, but using this 1, I can find for U3, which is going to be 1. See, they are sharing this 1 rupee and 1 rupee. And using this 1, I can write this as 1. Using this 3, I can write this as 2. And using this 2, I can write this as 2. See, if you add 2 and 2, you're getting 4, which means the cost is being shared both by the depot and the units. Is it okay? Is it okay till here? So we have done with the first table. The first table, our intention in the first table is to find U and V. Is it okay? Shall I proceed? Is it okay? Shall I proceed? Shall I proceed? So first table done. Let me name the table. Table 1. Now let me go for table 2. Table 2 is to find UI plus VJ for unoccupied cells. Okay. First table we found UI and VJ for occupied cells. Second table we are going to find UI plus VJ for unoccupied cells. So let me have the values A1, A2, A3, B1, B2, B3 and B4. What are the unoccupied cells? Let me place a dot for not to get confused. So B2, B3 unoccupied, B1, B4 unoccupied, and B2 and B3 unoccupied. So what is my U values? Yes, please join. 0, 2, 1. What are my V values? 2, 1, 2, 1. So what is this first value is going to be? 0 plus 1. So this is going to be 1. Am I right? This is 0. Huh? Sorry, I made a mistake. Sorry. This has to be 0, right? Because here this one, this has to be 0. Okay, I made a mistake. Sorry. So this has to be 0. Okay, if this is 0, this is 1, this is 0. So this has to be 0. Okay. This kindly ignore. Let me start from the first table now. So kindly ignore. Okay. So let us just take it for. We'll start from the beginning. Okay. Please excuse me. So table one to find U and V. Okay. Table one to find U and V. Okay. So A1, A2, A3, B1, B2, B3, B4. Okay. We are going to find U and V. So we are going to use the occupied cells from the VAMS method. Okay. And we're going to assume any of the U's to be 0. So U1 equal to 0. So this one I'll assume to be 0. So from the occupied cells, this value is 2. This value is 1. Okay. This value is 3 and this value is 4. See the logic what I did earlier is right only. Small calculation mistake. Okay. But actually it's wrong only, not a small calculation mistake or whatever it is. It's wrong only. So I just want to work it from the beginning. This is 2. Now we are starting over here. We are making an assumption that U1 is equal to 0. We start over here. So this is 0. This is 1. So this has to be what? 1. Okay. So 1 plus 0 is 1. This is 0. This is 2. So this has to be 2. Is it okay? Now this is 1, this is 2, so this has to be 1. This is 1, this is 1, so this has to be 0. This is 0, this is 0, this is 3, so this has to be 3. And because this is 3 and this is 4, this has to be 1. Please check whether it's okay now. Please check whether it's okay now. Yes, Bob. Would like to proceed? Let us go for table number 2. Shall I proceed? So in the first table, we find UI, and in the second table now, you find UI plus VJ value for unoccupied cells. Okay. So for unoccupied cells. So let us have the value A1, A2, A3, B1, B2, B3, B4. So this is unoccupied, this is unoccupied, here is unoccupied, and here it is unoccupied, here is unoccupied, here is unoccupied. So we'll go for the values returned, UI values. So the UI values are nice. So the U values here from the earlier table we copy U value 0, 3 and 1. V value is 2, 0, 1 and 1. So let us find A1, B2. So you added 0 plus 0, 0. Okay. That is U plus V. It is 0 plus 0, 0. This is 1 plus 0, which is 1. Am I right? This is 2 plus 3, which is 5. Okay. This is 2 plus 1, which is 3. And this is 3 plus 1, which is going to be 4. And this is 1 plus 1, which is going to be 2. Is it okay? So we found all the values. This is table number 2. Now let us go for table number 3. So table number 3, we are focusing on to check whether Dij, okay, what's Dij? Remember, Dij is equal to Cij minus Ui plus Vj is positive, negative or zero. If it is 0 or positive, then our problem is solved. If it's negative, our problem is not solved. Okay, so let me have all the columns written. A1, A2, A3, B1, B2, B3, B4. This you have to check only for unoccupied cells. Okay, so unoccupied cells, let me have a dot placed for convenience sake. This one, this one, this one, and this one. So these are the unoccupied cells. Let us go for A1 to B2. You have to go for Cij minus Ui plus Vj. Okay, Ui plus Vj you have found from table 2. Okay, what we did earlier. Cij you follow from the question. Okay, so you go for the question table and you get me the value for A1 to B2. So what is A1 to B2? His value. Can I get the value please? What is A1 to B2? A1 to B2 is 3. Please get me the value. A1 to B2 is 3. Okay. A1 to B2 is 3. So let me write it over here. So this is 3 Cij, right? Minus Ui plus Vj. What is Ui plus Vj? We found it to be 0 from the earlier table. So 3 minus 0 is going to be 3. Positive, no issue. Then A1 to B3, it is 5 from the question table I have taken. Minus this 1 I have. So 5 minus 1, 4. This is also positive, no problem. Then A2 to B2. A2 to B2 is 3. Sorry, A1, A2 to B1. It is 7 given in from the question we have taken. Minus the earlier table gives the value Ui plus Vj 5, which is 2 positive, no problem. Then for B4, A2 to B4 from the question it is 6 minus the value we have found from the earlier table 4, which is 2. Yes, positive, no problem. A3 to B1. A3 is A3 to B1 is 4 from the question I'm taking, and B1 is there is early table is 3, so it's positive 1, no problem. Then for B3, it is from the question table it's 7 minus 2 over here, positive, no problem. Yes, all values are positive, so optimality is reached. So what's the minimum cost we have spending here? Using the Ogle's method, which is 8,600 rupees. Is it okay? So that's all about transportation problem. Yes, please give a model question on not a standard problem. So if it's not a standard problem, you have to make it as a balanced problem. Then minimization is the objective. So let me focus on that point. So go for problem number 5. Here is a question which discusses saying that the ladies fashion shop wishes to purchase the following quantities for summer dresses. Dress size is given 1, 2, 3, and 4, and the quantity is given 100 units, 200 units, 450 units, and 150 units. So three size of dresses, size A, uh, A size, B size, and C size. Sorry, size 2, size 2, size 3, and size 4. And three manufacturers are willing to supply the dresses. So the manufacturers are named as A, B, and C. Okay, and they can supply total quantity of 150, 450, and 250. Okay, so how much they can supply? 150, 450, and 250. The shop expects the profit. Yes, please highlight. So it's the maximization problem. We have to convert this to a minimization problem. Okay, first thing. And what is the quantity required? 100, 200, 400, and 150. We have to check whether it's a balance problem or not. If you check over here, 150, 450, 250, it's 400, 850 comes over here, the total. And when you add up all these dress sizes, number of quantities required, 300, 450, 900 comes over here. See, here is 900, here is 850. So there is a shortage of 50 units where you need to add a dummy row. Probably this working, I'll show it in the board. Please join. So this is the one given. Okay. And what is the dress size given? So the number of units needed for each size of dress 100, 200, 450, 150. And what is the number of units the manufacturers can supply? From the question 150, 450, and 250. We add this, we got 850. We add this, got 900. So 900 minus 850, that's a shortage of 50 units. So we need to add a dummy because 50 is in shortage, right? We have to add it over here. So we add a dummy manufacturer D. See, there's a dummy manufacturer, which means what you're not going to purchase from that manufacturer, so no cost at all. So you'll include zero over here. Please highlight. You'll include zero over here and 50 units required from manufacturer D. But actually, we have not used that, okay? Because it's dummy only, no, we'll not use that. So if you do this, we will see the problem as a balanced problem. Okay, now we have to convert. See, the ordering is important. In the case of transportation problem, we have to balance that. Then you have to convert from maximization to minimize. So we have done it balanced. Now we have to convert from maximization to minimization. To convert maximization to minimization, from the whole table, go for finding the highest value. What's the highest value? So you have to include the zero also. What's the highest value? 5.5 is the highest value. And you subtract all the other values from this 5.5. So probably if I have the values written A, B, C, the three manufacturer, including the D dummy manufacturer, the dress sizes 1, 2, 3, and 4. What is this first value? 2.5, right? 2.5 minus 5.5. See, what is 2.5 minus 5.5? It's 3, negative, right? But anyway, we're going to talk about the cost. You can directly write as 3. Is it okay? You can directly write as 3. Negative 3 only, actually. If you want to write it as negative 3, don't, no worries, you can write it. It's understood. Because you're going to talk about cost, it's understood. Then you go for 4 and 5.5, which is 1.5. Am I right? You want to write it in negative, you can write it, or else you can just have the positive values and write it as cost table. Here is 5 and 5.5, so 0.5. Then 2 and 5.5, let me write it in brackets itself. 2 and 5.5, which is 3.5. Then for B manufacturer, 3 and 5.5, it is 2.5. Then B and 3.5 and 5.5, so this is 2 negative. Then 5.5, 5.5, 0. Then 1.5 and 4.5, 4. Then for C, it's 2 and 5.5. See, for all the rows and columns, 5.5 is the maximum value, that is the highest value. So for each and every cell, you subtract the same 5.5. Okay. So 2 and 5.5, which is 3.5. This is also a penalty method, right? Then 4.5 and 5.5, which is 1. 4.5 and 5.5, 1. 2.5 and 5.5, which is 3. And for D, everything is 0, which is 5.5. So highest negative. Okay, highest negative. So highest negative is not consider that one, am I right? So anyway, we are not going to consider the manufacturer D. He's a dummy manufacturer only. There is no such manufacturer available. Okay, this is the dummy manufacturer only, so they will consider this. So this is the standard problem. Hereafter, if you are asked to find MAMS method or NWCM method or LCM method or asking for optimality, we can do in a normal way. So this is a normal problem. Probably in your inter level, only the basic problems are being asked. So you need not worry about the next level in case it is not optimal what you have to do. So you need not worry about those things at all. Okay, that's